Section 7.5, and this is on inverse functions. The beginning of this is not calculus, it's pre-calc or trigonometry. They want to know the arc sine or the inverse sine of square root of 3 over 2, so you're asking yourself, what the sine of what angle gives you square root of 3 over 2, and that's pi over 3. And then part B wants the arc cosine of negative square root of 3 over 2. And so now you've got to think about the negative. The cosine, the arc cosine is allowed to be in 1 or 2. 2 is where the cosine would be negative. So when is the cosine square root of 3 over 2? Well, that would be at pi over 6. But that means the reference angle is pi over 6. So the angle we're talking about starts at 0 and rotates counterclockwise to get to that line, which would be 5 pi over 6. Part C, arc cosine of the cosine of 3 pi. Now we have to work our way inside out, so we work at this piece first, and the cosine of 3 pi is the same as the cosine of pi, and the cosine of pi is negative 1. So now you have to ask yourself, on the arc cosine, which can only be between 0 and pi, including 0 and pi, first and second quadrants, when is it negative 1? That would have to be at pi. And part D, remember your arc rules are the arc sine and the arc tan, you're allowed to be in 1 and 4, and the arc cosine is allowed to be in 1 and 2, because you have a positive quadrant and a negative quadrant. So part D wants us to do the sine of the arc sine of a half. So when is the sine of what angle gives you a half? Well, the sine of pi over 6 is a half. So now you're asking for what the sine of pi over 6 is, which gives you 1/2. That one undoes itself because it ended up in the same quadrant. Example 2. Suppose that theta is equal to the arc sine of 2 over 5. So arc sine can be in 1 or 4. Since that is positive, it must be in 1. The sine is the opposite over the hypotenuse. So this must be the 2 and this must be the 5. And if we use Pythagorean theorem on that, the square root of 25 minus 4, square root of 21 for the adjacent side. Now that we have them, all we have to do is figure out the two questions, and they want us to find the cosine of theta, which would be adjacent over hypotenuse, and the tangent of theta, which would be the opposite over the adjacent. And it's okay, leave your square root in the denominator when you get to calculus. Part B. This was part A. Part B wants us to find an alternative form for the cotangent of the arc cosine of x over 4 in terms of x. And so we're going to draw the triangle. Arc cosine, if this is my angle, cosine is adjacent over hypotenuse, so this would be the x and this would be the 4. And this guy would be the square root of 16 minus x squared. So if I'm now trying to find the cotangent of this, cotangent is the reciprocal of tangent. Tangent is opposite over adjacent. So cotangent will be adjacent over opposite. And there's the solution to that one. All right, example 3, we're basically proving an identity here. They want us to prove that the arc cosine of x plus the arc sine of x is equal to pi over 2. And if you draw it we'll just do it in the first quadrant. And we're going to call them, this one is going to be, let's see, we'll call this guy sine, this is x, and we're going to call, I'm trying to make it match the book so it makes more sense to our brain. And we'll call this one theta, and we'll let it be x. Because that way this means that this guy is equal to the arc sine of x, and theta is equal to the arc cosine of x. So that means I can put these two angles in the triangle. We'll call this one theta, and this one's, I think that's phi. And then we've got to say, oh, well, it's a triangle, it's a right triangle, so these two angles here have to add up to 90 degrees, but 90 degrees written in radians is pi over 2. So I've done it. It just says, this is it right here, the arc cosine of x plus the arc sine of x is equal to pi over 2. There really wasn't much to that one. Okay, let's go to example 4. They went through the rest of the arc functions for you. And now they want us to find the arctan of -1 over the square root of 3. Okay, tangent's allowed to be in 1 or 4. It's negative, so it must be in 4. When is the tangent, if I rationalize this, because most people have memorized it like this, when is the tangent square root of 3 over 2? That would be at pi over 6, so this angle is pi over 6. And I could go around, since we're going from -4 to 1 on my quadrants, that would be negative pi over 6, because I'm rolling backwards. And that was A. B wants us to do the arcsecant of -2. Arcsecant is reciprocal of cosine. Cosine's allowed to be in 1 or 2. It's negative, so it's in 2. And the secant is the reciprocal of cosine, so cosine is adjacent over hypotenuse. So hypotenuse over adjacent, so this is 2 and this is 1. Okay, when is the cosine a half? Cosine is a half at pi over 3. So this guy is pi over 3, but I need the angle that gets me there. And so that would be 2 pi over 3. And then part C, the sine of the arctan of x. Okay, again, draw a triangle. Arctan, tangent is opposite over adjacent, so this would be, if this is my angle, it would be x and 1, which means this is the square root of x squared plus 1 squared, or 1 plus x squared. And now just do the sine of this. The sine is the opposite over the hypotenuse, so that would be x over the square root of x squared plus 1.